Hello everyone, today we are going to present the bendable concrete. This revolutionary material that was discovered recently, and we will go through some potential application of this material in Qatar. Well, I would like to start by introducing how people used to build their structure in the past. It used to consist of 1 to 3 floors, but now we are building much larger and taller buildings that is capable of withstanding more people, more loads, and so on. All of that happened because of this amazing material, which is the concrete. Well, you may ask, what's the concrete? Well, it's an ancient material that's basically made up of aggregate molded by cement. And since changing the recipe will change the properties, we can work on this field to improve our concrete for our applications. For example, the Romans used volcanic ash to provide or add some more waterproof properties for the concrete for building bridges, water transporting systems, and so on. And same applied for the modern concrete. We're still using cement, sand, and natural gravel or admixtures. And interestingly enough, this material is capable of withstanding up to 1,000 pounds per square inch of compressive stress, but not so much for tension. In fact, it's only about 5 to 10% of of that value. Now let's have a look on the structure. We have the aggregate and the cement. When we apply the compressive force, we are making the cement distributing the load within the material, and the aggregate is also contributing, which make the material withstand huge amount of load in the compressive force. But it's a completely different story when it comes to tension. When we apply the tension, the aggregate is no longer contributing. It's all up to the cement to withstand that load. But since cement is not that strong, fracture will occur in the system. And here's the challenge. We are applying load for our structure, make it bend, and bend make the material experience a compression on one side, which we have no problem with, but a tension in the other side, which make the material fracture. And here's where bendable concrete comes into the play. We are capable of adding polyvanillin alcohol fibers or PVA, and that allows us to build the stronger concrete from the tensile perspective, where we are introducing fibers within the cement that can make it bond, that can ensure the presence of the bond within the cement to the aggregate, and that will distribute the load within the material. It works similar to how the tree's root work in the soils. So by doing that, we are capable of building concrete that's capable of withstanding up to 300 times more tensile load than the normal concrete. And this is a huge advantage because now we are capable of building much stronger and more durable concrete. And at the same time, this concrete requires less emission of CO2, and at the same time it's 20 to 40% lighter, which I personally believe is an amazing property because we are now capable of building the structures stronger and larger with while saving energy. Also, interestingly enough, this material is capable of self-healing, and this is an important property because now we are capable of building a structure that's more durable and can last for long time without maintenance. And here, well, we have an example of a structure built up of completely bendable concrete. And let's jump into the disadvantages. Of course, every new technology has some disadvantages. Now, first we start by the cost. It's an expensive technology and it requires high cost for the initial investment. It also requires the worker to be trained on this new material, and also this material, the quality of this material depend heavily on the condition it's made in, where it have significantly varying properties. How about the potential application here in Qatar? Well, the roads is a potential application because Qatar is capable of producing concrete because we have here more than 10 local companies that produce concrete, such as Qatar Concrete, for example. Also, the roads that are built up from bendable concrete can handle greater force and can self-heal, so it requires less maintenance and can withstand for a long period of time. And here we have a nice example where bendable concrete is used in this ECC link slab, where it can withstand the stress and the tensile stress, the compressive stress in this moving street where it opens and closes. Also, it requires less maintenance and can last for a long time. Another potential application is generation of energy. By introducing polyvanillin difluoride or PVDF, it allows the material to generate electricity. This polymer acts similarly to a strain gauge, where it allows the production of potential difference by applying varying strain. By introducing this material, we might be able to light the streets and the traffic lights with this energy generated by the concrete. So as you can see, we have a huge application and we have huge advantage when using this material. It allows us to build up stronger, larger, lighter, and at the same time require less maintenance structures that can shape our humanity, that can shape our civilization in the future. So I hope the video help you understand what spendable concrete is, and I hope you enjoy the video. Thank you.